Hey class, this is lecture for Unit 2 for Psych 2317 for statistics for the behavioral sciences. So I'm just going to lecture through some slides and some concepts as we talk about what we'll review a little bit of what we talked about in Unit 1, and then we'll move on to standardized scores and chat about those for a minute. So let me share my screen. Okay, so lecture on number 2. What did we do in our last video? We learned that statistics is the science of inferring something meaningful about a population when all we have is a sample. Because we can't go out and poll, every third grader in America. We need to get something useful from our sample population, our sample of our population. And we remember the two properties we use to describe the data set are the center and variability, right? Our mean, our average, and then our variability or variance. So the measures of central tendency we learned about were mean, median, and mode. And our variability measure was variance and standard deviation. Remember all that? Awesome. If you don't, rewatch that video, even though it's a little cringy. Sorry about that. So now we're going to learn about standardized scores and how we can use those, how we can convert from raw scores to standardized scores, and then how we could convert back. So sometimes we want to compare a single measurement to other measurements. So say you're on a college acceptance committee, right? And you're making admissions decisions, and one applicant sent in their SAT score and another applicant sent in their ACT score. So if applicant one scored 1270 on their SAT and applicant two scored 30 on the ACT, which one's better? Well, I don't know because we have to do some statistics to figure that out, right? That's comparing apples to oranges. And so we can't say which one is better unless we have some score that could equalize them and compare them both appropriately. Because those are different measurement scales, we need a standardized score so that we can look at them beside each other. So to do standardized scoring, you need the mean and the standard deviation. So for whatever assessment or group or data set you're looking at, you're going to need the standard deviation and the mean if you want to compute a standardized score. So for the SAT, at the time of these notes, maybe it's changed by the time you're watching this, but at the time of the notes, the mean is 160 with a standard deviation of 210. And for the ACT, the mean's 21 with a standard deviation of 6. So we know that both applicants scored above the mean, but how far? Okay, they both did better than the mean, so that doesn't help us know which one really did better. So applicant one had a 1270 on the SAT. Well, we know that standard deviation is 210, and that's 210 points above the mean, so they're exactly one standard deviation above the mean. Applicant two scored a 30 on the ACT, and that's 9 points above the mean because we know the mean is 21. And so if standard deviation 6 and they scored 9 above it, that's 1.5 standard deviations above the mean. Well, that means that applicant number 2 did better. Good job, applicant number 2, because you scored 1.5 standard deviations above the mean instead of just 1. So if we could only take 1, I'm probably going to take applicant number 2, unless they have some killer references or something like that. So standardized scores are called z-scores. We take a raw score, and that's the value in the original scale of measurement. And so we take our raw score minus our mean equals our standard deviation. So you can see here, this is our symbol. So we'll do this for z-score. So it's kind of like a z with a line through it. Now the formula is raw score minus mean. So raw score is x, right? Whichever data point we're talking about for this particular problem or z-score minus, wait, what's this? Oh my goodness, this is mu. So that's a Greek symbol. And so this is what we're going to use pretty much exclusively from here on out for mean, for our population mean. And then I think we talked about sigma a little bit last week. So that's the standard deviation of the population. So all we're saying in this formula here is your z-score is your score, your raw score minus the mean, minus mu, divided by your standard deviation, divided by sigma. So maybe write this down on your cheat sheet, keep this, but it looks kind of scary. Just know that this is probably what you'll see in your homework problems or on your tests, but this is what it means in words. So feel free to write those beside each other if that'll help you out. So a z-score is a variable whose value counts the number of standard deviations a score is from the mean, either above or below. If that's all you got out of this lecture, is that a z-score is the number of standard deviations from the mean, that's it. That's perfect. That's golden. Everything else we'll talk about is applying that sentence right there, but just knowing that a z-score is the number of standard deviations from the mean. That's it. That's what this whole unit's about. So z-score and z-score 0 is the mean. So we have our bell curve here, right? And we have our mean going down the center. That's always 0. So we're seeing how many standard deviations away from 0 we can get. So for z equals -1, that's one standard deviation below the mean. For z equals +1, that's one standard deviation above the mean. And that's always the case. That's always how it is in z-scores. So for z equals 2, that would be 2 standard deviations above the mean, right? And so on and so forth. So what kind of problems can we solve with our z-scores? We can convert raw scores to z-scores, like we just did with the SAT, ACT example. We could also convert z-scores to raw scores. So maybe you know the z-score or something, but you don't know, well, what was that score actually? And then we can take those two things and we can use them to figure out something else. We can convert a raw score on one measurement scale to a score on another. So say we knew someone's ACT scale and we could figure out their z-score from that, right? We had their z-score and their raw score. Well, then we could use that to figure out what a comparable other score would be on the ACT or the SAT. I'm getting the letters mixed up, right? But we could use one to figure out the other. So to convert raw scores to z-scores, here's our formula here. Z equals x minus mu divided by sigma. So for exam 1 and exam 2, here's our mu and our sigma. So for exam 1, we have the mu equals 63.95, sigma equals 4.31. And for this, we're just using x68. We just picked a random number from in here. So the z-score, z of 68, because that's the number we chose, equals x minus mu divided by sigma. So here's what this looks like. And if we wanted to see what the z-score would look like for exam 2, we do the same thing. So we'll pick a random data set. We're going to pick x equals 87. So we're picking this one right here. So our z of 87 equals this. So our two z-scores are 0.94 and negative 1.21. So now we can compare how someone did on their first exam to how someone did on their second exam and see, well, are they getting better or worse? Because the scores were different. We don't know that they were equivalent, but now we can compare these z-scores. What if we want to convert a z-score to a raw score? Well, we just kind of do it backwards, right? We look at what raw score is associated with the z-score of 1.33 on, for example, the GRE. So we have mu of the GRE equals 500, and the sigma of the GRE equals 100. So if the z-score is 1.33, x equals 1.33, well, times by 100 plus 500 equals 633. Now, what if we want to take it from one measurement scale to a different measurement scale? Say we know someone's IQ is 120. What's their equivalent GRE score? I don't know. How could we possibly know that? We can because we can do z-scores. So we can transform that raw IQ score to a z-score. So we have our IQ score to a z-score. So we need to know our mean and our standard deviation. So here's our mean and here's our standard deviation. So we can compute the z-score, 1.33. And now we can transform this z-score to a raw GRE score since we know the mean and the standard deviation. So now we know that their approximate GRE score would be 633. We got that because we knew that their IQ was 120 and we knew mean and standard deviation. That's it. Amazing, right? An entire unit in, what am I at? 6 minutes? I can't tell. However long I've been recording. Pretty quick, right? So just remember that a z-score is the number of standard deviations from the mean. And look at that. And then I'll post another video working through a couple of problems probably for your homework/unit chapter assignments. Okay, that's all.